Okay, in this example, we're going to look at how to solve a quadratic equation. And so this one's a little bit different because it's a trig equation that has more than one factor involved. Okay, so again, determine all solutions for the following equations on the given interval, and then determine exact solutions where possible. Okay, and so the first example we're going to look at in this question is 2 sine squared x plus sine x minus 1 equals 0. And so what you'll notice here is that you have a sine squared term. It's kind of hard to isolate sine x because there's more than one sine term. And so what we're going to do is try to actually factor this. So think of the sine x term. So think of sine x as y. Okay? So if we let y equal sine x, what this would actually look like is 2y squared plus y minus 1 equals 0. Okay? And so what this ends up being is a complex trinomial with a product of -2 and a sum of +1. And so if I try to factor this, this would be 2y squared plus 2y minus y minus 1 equals 0, which would factor to 2y times y plus 1 minus 1 times y plus 1 equals 0, which gives me 2y minus 1 times y plus 1 equals 0. Okay, so far this is what it would look like if I'm trying to factor it. Okay, so if you let a different variable represent your function, it makes it a little bit easier to try to factor it. Okay, and so what this would look like if I replace y with sine x is 2 sine x minus 1 times sine x plus 1 equals 0. Okay, so if you find that it's a little bit challenging to try to factor a trig function that's got an exponent of 2, by factoring, it's much easier to replace the function with the variable and then factor it based on the principles that you learned in grade 10, and then replace the variable with the function that you're looking at. Okay, and so I've already done that here. And so I have 2 sine x minus 1 times sine x plus 1 equals 0. And so what this means is I have two factors and the result is 0. So either the first factor is equal to 0 or the second factor is equal to 0. And so if I simplify this, I get sine x equals 1/2 or sine x equals -1. Now, the first one here, you'll notice that I have sine x equals 1/2. And based on my special triangles, I know that there is a ratio where the opposite over hypotenuse sides would be equal to 1/2. And so that's an opposite side of 1 and a hypotenuse of 2. So opposite to 1 is pi over 6. So I know there is a special angle there, and we'll come back to this in a second. Sine x equal to -1, there is no special angle for this one. No special angle in our special triangles, and that is what I mean. But what you'll notice is that I graphed the sine function on the right-hand side here, and the value of x that'll make this function equal to -1 is actually the value here. So here's sine x equal to -1, and so the value of x that makes this statement true, based on the graph, is 3 pi over 2. Okay, so for this equation here, the only value of x that makes this side true is x equal to 3 pi over 2. Okay, and you'll notice that I sketched the sine function from 0 to 2 pi, just like the domain of x is stated here. Okay, so this equation, this linear equation that we have here, has one value of x that makes the statement true. Now, the other equation that we have here, which is sine x equal to 1/2, will have more than one solution, and you can see that graphically as well. If I look at sine x equal to 1/2, so there's 0.5 there, I have more than one solution. I actually have two solutions. Okay, the first solution falls in quadrant 1, and the second solution falls in quadrant 2, which is what we would expect because that's where the sine function is positive. Okay, so I'll have a solution in quadrant 1, and I'll also have a solution in quadrant 2. Now in quadrant 1, x is going to be equal to whatever your special triangle angle will be. So we'll look at that based on our special triangle. Okay, and so we had said earlier, we have an opposite side of 1 and a hypotenuse of 2. So opposite to 1 is pi over 6, and there's a hypotenuse of 2. So x is equal to pi over 6 in quadrant 1. Now in quadrant 2, you're looking at pi minus the special angle. So you have x equals pi minus your special angle And so again, you'll need a common denominator. So that's going to be a common denominator of 6. And you get x is equal to 5 pi over 6. So you actually have 3 solutions in this equation that satisfy the equation that was given here. Okay, so you have x equals pi over 6, you have x equals 5 pi over 6, and then you have x equals 3 pi over 2, which are your 3 solutions in this equation. Okay, so therefore, x is an element of the set of numbers that include pi over 6, 5 pi over 6, and 3 pi over 2. Okay, for example 2 part B, we have 2 times sine x cos x plus sine x equals 0. And the domain of x that we're looking at is between 0 and 2 pi. So we're looking at one cycle of the function. Now, what you'll notice in this case, is that we have something that looks a little bit more complex. There's no way to isolate only one of the functions. And so you'll notice that we have a sine x term and we have a cos x term. In order to try to solve this equation, we need to try to have it in factored form, just like we saw in part A. And so if we look at the 2 terms that we have here, the common factor between the 2 terms is sine x. So I'll start by factoring out sine x. And what I'm left with is 2 cos x and then plus 1, and that is equal to 0. So now that we have it in factored form, you can see that we have 2 things that are being multiplied. Each of the factors individually are based on only one function. So that means we should be able to solve this. Okay? So our first function is sine x equals 0. Or our second function is 2 cos x plus 1 is equal to 0. So there's the 2 parts that we're going to try to solve. Okay? And so this one I can't simplify any further. I just have sine x is equal to 0. So what that means is I need to find values of the angle x such that the equation would be equal to 0. And we'll look at that in a second. And then for the second part, we have 2 cos x plus 1 equals 0, which means cos x would equal -1/2. So I need to find values of the angle x such that the cosine function would be equal to -1/2. And now just to help me solve this, what I'm going to do is I'm actually going to look at the sine function. And so here's my sine function here. I drew it at the top. And there are specific values of x that make the function equal to 0. And you can see that at 0, pi, and at 2 pi, the function is equal to 0. Okay? So this one's pretty quick to solve. X would be equal to 0, pi, and 2 pi in one cycle. And so there's 3 solutions so far that we have that would satisfy this equation. So if I plug in x equal to 0, x equal to pi, or x equal to 2 pi in this equation, then the left side would be equal to the right side. Now for cos x equal to -1/2, this is going to be using one of our special angles. And I recognize that because it's not 1 or -1 or 0, so that makes it a little bit easier to recognize. There's definitely a special angle that'll give you an adjacent and hypotenuse side that's 1 and 2. And you can see on the graph that there's actually going to be 2 values. So if I look at -1/2, it's there and there. So there are going to be 2 values. And what you can see is that this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. And so the angles are in quadrants 2 and 4 that we're going to, quadrants 2 and 3 that we're going to be looking at. Okay? So let's take a look at what the angle would look like. We'll draw our special, our terminal arm diagrams as well to help us figure this out. So quadrant 2 looks like that. Quadrant 3 looks like that. And so to look at our special angle, here we go. I'm looking for an angle where the adjacent side is 1 and the hypotenuse side is 2. So here's 1, adjacent to that is pi over 3. So adjacent is 1, hypotenuse is 2. So that means my related acute angle here is pi over 3, and so it's the same thing in quadrant 3 as well. Okay, so I need to solve for the angle in quadrant 2, which means in order to solve for this angle here in quadrant 2, I need to subtract pi over 3 from pi, and again get a common denominator, and subtract, and you get x is equal to 2 pi over 3. So there's one of my angles. The other angle, which is the one that's going to be over here, I would solve for that one by adding pi over 3 to pi. So it's going to be a little bit more than half a rotation. So I'll find the angle in quadrant 3. And so x is going to be equal to pi plus pi over 3. And so that's going to give me 3 pi over 3 plus pi over 3. So again, get a common denominator, which makes it 4 pi over 3. Okay? And so that's the angle that's in the picture over here. Okay? So there we go. We have 5 solutions again that satisfy this. And so therefore, x is an element of the set of numbers that include 0, 2 pi over 3. You have to write this in order from lowest to highest. Pi, 4 pi over 3, and then 2 pi.